The amount of change of a function on the interval a to a plus h is defined to be f of a plus h minus f of a. So on this same interval, a to a plus h, the average rate of change is defined to be f of a plus h minus f of a, and then you divide it by a plus h subtract a, which is just h. The most important one, which relate to derivative, is the instantaneous rate of change. And we sometimes just simply call it the rate of change. So it is defined to be limit as h goes to 0, f of a plus h minus f of a divided by h. And that is why the rate of change sometimes is also called f prime at point A. Okay? When we're talking about the instantaneous rate of change, we're talking about is at one point, at the point A, x equals A, because it's one instant. So these are some definitions that you need to be familiar with. And with this definition, okay, we can see that what if we are not taking a limit, or what if the change h is small enough? When the change is small enough, from the formula we can say that f prime of a is approximately the quantity f of a plus h minus f of a divided by h. Now what this tells us? This tells us that we can estimate. We can estimate the quantity f of a plus h if we already know the rate of change at a. How do we estimate? We solve for f of a plus h in this formula. So f of a plus h will equal, so you multiply f prime of a times h, and then add f of a to both sides. So f of a, you would say not equal, approximately f of a plus f prime of a times h. So how do we use this formula to help us solve problems? So let's take a look at this example. Given f of 10 is -5, and you know the rate of change f prime at 10 is 6. Can we estimate f of 10.1? So we don't know f. We don't know much about f. We don't know the expression. All we know is at 10, f of 10, we have -5, and f prime of 10, so the rate of change at 10 is 6. Well, we use a formula that we just discovered earlier. So it's f of a plus h. When h is small enough, it's approximately f of a plus the rate of change times the change. So now we just need to break it up. Okay, so f of 10 plus 0.1 is f of 10.1. So it will equal f at 10 plus f prime at 10 times the change, which is 0.1. Now we can plug in the number. We get negative 5 plus 6 times 0.1. And if you use a calculator, you get negative 4.4. So it will give us some information when we know the function value and its rate of change. It will help us estimate small value that's nearby. And what about f of 9.9? Can we estimate f of 9.9 when we know f of 10? Yes. Okay. So how do we estimate? We need to recognize what is your a here. Your a is not 9 because we don't know 9, but we do know 10. So a is your 10, but what is your change? Your change is negative 0.1. Okay, so your h is negative 0.1. Same thing, you get is approximately f of 10 plus f prime of 10, but at this time your h is not 0.1 but negative 0.1. So you will get negative 5 plus 6 times negative 0.1. So it'll be approximately negative 5.6. And these are just estimates. Give us an idea of how the function f, the value of the function f near the point 10.